Good morning, good afternoon, and good evening, everyone from all around the globe. My name is Eric Mann. I'll be helping moderate today's webinar, Interactive Development at Scale on JuliaHub. From VS Code to Pluto Notebooks with on-demand compute, including GPU compute, JuliaHub makes it easy to interactively deploy and develop your code. Exploit the power of an on-demand cluster to rapidly iterate on big problems. Dr. Matt Bauman, Julia Computing Director of Applications Development, will demonstrate some of the key features of Julia development and JuliaHub and guide you through writing your own notebooks and scripts for interactive data exploration. We'd like to have this interactive session today, so please write your questions in the chat. We'll either address them on the fly or address each question individually following the demonstration. With that said, it's my pleasure to introduce today's presenter for the webinar, Dr. Matt Bauman. Matt is the Director of Applications Engineering, as mentioned, has a PhD in bioengineering from the University of Pittsburgh, and is a longtime contributor to the Julia language. Matt?
Thanks so much, Eric, and welcome everyone. Thanks for joining us on this Friday afternoon. I'm really excited to show off some of the new things that we've been doing with JuliaHub, and in particular today I'm going to be focusing on those interactive development environments where we can use JuliaHub to work and iterate and explore on things interactively. For those of you who are new to Julia, I always just like giving a brief overview to the language itself. But most of the time will be spent on JuliaHub itself. We'll talk about what JuliaHub has been doing and kind of the main goals. But really, I want to dive into some demonstrations of using Pluto Notebooks, which are a kind of a Julia response to Jupyter Notebooks with some really cool interactivity features, as well as more structured development environment of VS Code. We'll talk a little bit about how the data works, both in terms of the code that you write, as well as data that you're processing, and kind of take a sneak peek at some of the bigger compute capabilities that are at your fingertips from within this interactive environment. We'll be spending more time next week talking about that, but we'll see, kind of scratch the surface today. So the Julia language is a great language. I'm a huge fan. I'm sure many of you are here because you're also big fans. It's a modern programming language that's designed to be fast and expressive, and that's really important for the things that we're talking about today, because we're really going to be focusing on iterative development, interactive exploration, and the ability to just kind of write your code and do so at a high level, play around with it and see what things look like. We'll do so first just kind of by looking at a little toy example. Mandelbrot Set is this example that is often used to kind of demonstrate compute and particularly parallelism. It's something that kind of is this really cool, complicated behavior that comes out of just 13 lines of Julia code. And so we'll take a look at how this works in practice in an example and kind of see what's happening here. The key thing, though, is that this is extraordinarily fast as well as being expressive. So you can play around with some very simple definitions, get some really complicated responses out of it, and do so interactively. We'll see what this looks like in a Pluto notebook and kind of explain a little bit about how the code works here. But perhaps most importantly, once you have your solution interactively developed, it's going to be fast. Just this simple definition with no special annotations, no types, no performance tricks or anything like that. We are, generating more points per millisecond than really any other language if you write it this way with a for loop in your language as an iterative solution. And that's because for loops in Julia are fast. So we're able to, compute 10,000 points of our image every millisecond, which is wild and fast, and faster than some of the traditional languages. But let's dive into JuliaHub. Let's see how this looks and how this works. And we really see this as being a complete workflow for everyone from data scientists to engineers to, as the world kind of muddies the water between those two positions. We have on the left a completely interactive integrated development environment leaning on VS Code, which is an awesome interface for doing all sorts of interactive plotting, exploration, and development. And on the right, we have Pluto Notebooks, where you can inspect and iterate and play around with things, and kind of tying them together within the VS Code environment is the ability to do validated and scalable job submissions that can be reached and worked on from either environment. So for the demos today, this is really where I want to focus my time. We'll start off with Pluto Notebooks, where we'll kind of see what that Mandelbrot set looks like and play around with how that works. We'll also take a peek at what some of the awesome folks at MIT are doing right now with Pluto Notebooks, and how you can load in those notebooks in JuliaHub, play around with them, and get working on some of the really top-notch training and teaching materials they're developing there for how to think about computers and algorithms. Then we'll jump over to the Julia IDE, where we'll launch a VS Code. I'll talk a little bit about how the data are structured, both for your code as well as data that you want to process, as well as how you can interface with GitHub, your Git environments. And then we'll bounce back to Pluto again, where after working in the IDE for a little bit, iterating on a process, we'll submit some jobs that we can run, kind of spin off some jobs that we can run separately and kind of run a bunch at a time potentially. And then we'll come back to Pluto to inspect those results. So that's the roadmap for today. Really, we're just going to dive over to JuliaHub.com. So let's do that now. If you go to JuliaHub.com and bring this on your screen with that before you log in, you'll see a splash screen like this. We just want to log in. You can do so with any of these authentication providers. And really, this is just how we build your account. And so we can do this this way. Let's see here. Oh no, why can I not get my... well, we'll do it this way. We'll use the open authentication. Oh, but I'm in sorry about that. So yeah, I'm already logged in. I wanted to show you the logged out page. Let's just go to a non-incognito session to see the logged in page. Sorry. There we go. So you can see once you've logged in, you're at this landing page now, where we really want to focus on our interactive applications, our interactive development experience, where we can directly launch and work with the Julia IDE and Pluto Notebooks, as well as kind of see the jobs that we are currently running. So I already have spun up a Pluto environment and a Julia IDE environment. Those are running. You can also see the jobs that I've finished, where we have these jobs available. You can look at their logs, see how they ran, and some of their results as well. We'll look at what that looks like as well. The old JuliaHub interface is still here, and you can still go in and explore the package ecosystem under the Explore tab, where you can go in and look at all the awesome packages. For example, you can find Pluto Notebooks, dig in, find the documentation, learn all about how Pluto is working and the kinds of things that Pluto does through JuliaHub directly. I want to go back to the main page though, and just launch a Pluto application, right? And so I've already done that. My button here already says connect because I've already launched a machine for me. If I hadn't, this button would say launch, and I could click this launch new instance button, where I can choose exactly what kind of capability I want to put behind my Pluto notebooks. So if it's a small task that I'm working on, I could use a cheap instance, right? There's no need to throw money if I'm not going to make use of multiple cores or lots of memory. Where this really becomes powerful is the ability to start a Pluto notebook that's backed by a GPU, where locally on my desktop computer, even though I have a reasonably modern machine, I don't have access to a fast computational GPU device, which is essential for training neural networks and many other sorts of algorithms can see, 10 to 100 to a 500-fold speed up if you can express them on a GPU. And it's just absolutely huge to do so. So being able to get a GPU at your fingertips is definitely one of the killer applications here. I'll just use a CPU job, and you can start this up. I've already done that. And so instead now I can just hit connect. And once you do so, you see the standard Pluto interface where we have our, general session, and you can play around with it, see what all is available. Once this loads up, we'll be able to open, create a new notebook or open a sample notebook. You can poke around and see this. You can also load from a file. So you can grab out a file to do that. Let me log in here. There we go. So once I'm logged in, I can go in here and open a file. I can see my recent sessions and even some that are currently running. I can pull those up and look at what they do. So let's connect to this Mandelbrot example that I had on my slide just a few minutes ago. You can see I have exactly the same definition as what I had on the slide. And this is just kind of a mind-boggling sort of algorithm here, where it's really quite simple. We just have a point. In this case, it's a complex number, but you can think of it as kind of a point in space. It's just kind of an XY point. We take it, do some computation with it, just kind of iteratively square it, add its initial value back in, and just see, hey, did that process, end up creating a value, an absolute value greater than 4? And if it did, let's return how many times it took to get there. It's really quite simple. But out of this, you get really, really fancy behaviors. So we can do this across a lot of points in a data set just by using an array comprehension here, where, for a bunch of Y values, the columns, you just pick out what values you want to look there, and a bunch of X values on the horizontal axis, see where we want to be on the complex plane, or kind of think of it as a Cartesian plane. And you can see the numbers that we get back. So the number of iterations that it took to break out of our absolute value check here, right? So in the middle of our blob, we can see it took all 80 iterations. That's kind of the default maximum, right? We'll stop after 80 tries to break out of our test here. So in the middle, that's these 80s, and on the outside, the values are starting bigger, so it takes less iterations, right? It only takes 2 steps, and then suddenly our absolute value is greater than 4. Just by kind of squinting and looking at these numbers that we get back, you can kind of see that structure that we had in the kind of classic image of what people display when they look at a Mandelbrot set. But really, we want to do one better. We don't just want to look at the numbers. Let's look at the values as though they were an image, right? So if we kind of take a bigger range of values, you can get exactly the Mandelbrot set as you would see on Wikipedia or something. And really all we're doing here is telling Julia how to interpret, the number 1 versus 2 versus 80. And it's just a matter of saying how, in this case, I chose to make it shades of blue. How deep blue do you want those numbers to be? And the cool thing here is you end up with these really wild behaviors at the boundaries around the points at which you escape. So what makes Pluto so great is that it is entirely responsive. So changes that I make in the notebook are automatically reflected in the images that are printed out here. So for example, I can zoom in on a particular point and you can see the complexity as you zoom in, which is just really, really awesome. You do it a little slower. Hopefully it works across the video. But you can see this really complicated behavior. And as I zoom in, you can see more and more points are hitting the maximum iteration, that 80 number, right? And so, or in this case, it's 100. I can increase that value and get more and more definition to my values here and continue zooming in. And as I do so, right, Julia is just dynamically generating all the points. There's many hundreds of thousands of points that I'm generating at any given point here, and doing thousands of iterations at each point potentially. And yet we're able to generate these extraordinarily fast and responsively. And you can actually see, drawing of this image here took 245 milliseconds. So that's how you get these really cool responsive sorts of things in your Pluto notebooks. And this is all just running on JuliaHub. So that's just a very, very simple example of a Pluto notebook that allows you to kind of explore and see and understand the values that we're looking at and kind of get a sense of, from a very simple function, right? This is all we're looking at is a very simple function. Just by interpreting the data as an image and adding a few sliders, we get this really awesome interactive, almost like a dashboard, right? And you can imagine how you can apply this to your own data, your own algorithms, exploring this. And really, no one's been making better use of Pluto notebooks than Professor Alan Edelman and his team at MIT on their computational thinking course, where you can go and check out the work that they're doing. And of course, they're doing it all in Pluto notebooks. So you can load these in to JuliaHub as well and see how these things work. Of course, some of the most fun examples here, you can go in and just kind of look at some of the really cool examples that allow you to do sorts of Inception-like things here, where you can actually enable your own webcam as you're talking, take a picture of yourself and do all sorts of fun image processing on yourself, and even in some cases do it live. So you can play around with this and follow along with the course at MIT. It's an entirely open course, and they're doing some really awesome things with Pluto notebooks in general. And these notebooks all just work on JuliaHub. So those are the initial examples that I want to talk about today with Pluto. So I can close this. Let's jump over to our Julia IDE and kind of look at how we have these jobs structured and how we can build and develop more and more complicated examples as we go. So I can connect to my Julia IDE session, and it pulls up VS Code in the cloud. In my browser here, I have a VS Code window that is tied to whatever execution resource I connected to it, right? So this could be a 32-core machine. It could be a machine with GPUs, just like how we specified our Pluto notebooks. And you can see that, by default, we start up with a nice welcome page. There's also a code directory here that's open by default that stores some of the work that I've been doing. When you launch this will be empty for you, and this is your scratch space to work on and develop and work with. One of the first things that I like doing when I launch a VS Code session on JuliaHub is break it out of the browser. And what I mean by that is Chrome and some Chrome-based browsers and others are adding this capability as time goes on as well. They have this concept of I think they call it a progressive application, where you have a web-based app like this, right, where it's entirely constrained in my browser window. I can bust this out of my browser window just by pressing this button right here at the top of my URL bar. It's this tiny little button that kind of looks like a download. And it says, if I hover over it, it says install code server. I click this, hit install, it'll break out from my web browser into a real application, which is awesome. If for no other reason that now when I hit Command W, it actually closes my tabs instead of trying to close a window. This allows you to work with VS Code much more naturally, as though it were a real process, as though it were a real application, right? It's no longer tied to my web browser. I'm no longer tempted to go off exploring other corners of the web. I can focus and look directly at my work here. So, if I started with a blank slate, how do I get my work onto VS Code so I can make use of all of the cores, all of the capabilities that we have here? There are several ways that you can do this. One way is to grab a project from your local directory, right, where you have where you have some sort of project and you want to pull up a you want to bring in some example of your data, of what's or of code that you've already written. One of the easiest ways to do that is just to grab a folder from your computer and take it and drag and drop it. And that will actually just upload your data directly, all the code, all the data into JuliaHub. And you can see the progress down here at the bottom, allowing you to monitor this. This is uploading it to my space that's persistent here. And now I have access to whatever sort of things that I put in here, be it data or code or Jupyter notebooks or Pluto notebooks. It's all available to me directly here. The other way that we can get and explore our data or do this is by connecting to GitHub. And one of the best ways to interface with VS Code, if you're not familiar with it, is through the command palette. So of course you can browse to it through the menu here, go view, command palette, right? And that will bring up this kind of command line interface to your editor, which is an awesome way of working. I tend to just memorize the keyboard shortcut. On a Mac, it's Command-Shift-P. On Windows and Linux machines, I believe it's Control-Shift-P. Allows you to work and play with these things. And so I could clone a repository. And I could even do that directly from GitHub, where VS Code will connect to my account it authenticate. I've already authenticated, so I don't need to go through that step here. If you've not, it'll just ask you to log in, bring up a new browser window, log into GitHub with your credentials, and then, for example, I could go over to MIT Math and grab that 18S191 course which is, that Introduction to Computational Thinking course. This will grab it and prompt me to clone it to the machine in the cloud, right? This is, again, on the computational resource that I requested. And the key part here is that I want this to end up in my data/code directory. And I've already done this, but I'll just put it in the temp folder here. And so the, data/code, oh yeah, I guess. Yeah, it'll say that I've already done this, I think. Or, oh, I guess it'll make a new one. Cool. So you can see I've already done this. And this data/code directory is the directory that is persisted. It's the directory that is where, JuliaHub expects me to save my files to. It's the directory that is actually shared between Pluto Notebooks and VS Code notebooks. So for example, if I go back to my JuliaHub session here and connect to Pluto again, I can actually browse and see all the things that I've been doing in that data directory, where inside here in data/code, we actually have, that 18S191, which is the MIT course number for that course that I've been talking about. We also have the one that I just added, right? This directory is persistent, it's stored, and it's shared across all the interactive applications that you run on JuliaHub. So, we can go in here, grab out a different notebook, and potentially look at all of the different sorts of things that they've been doing. And again, this is grabbing that Pluto notebook that I just installed on my VS Code. So that's kind of one of the powerful features here, is that this data is shared and allows you to connect to all of your applications. Now, to kind of bring this all back together, I want to do a training example that I've done in the past as well, where we're going to load up a machine learning model, kind of this hello world of machine learning that classifies handwritten digits using this classic data set called the MNIST digit data set that allows us to train a network and play with it. And this is one of those neural network sorts of structures that really benefits from using a GPU. Right. So I could potentially, if I wanted to, go in here and start a Julia REPL, right? Again, using the command palette, bring up a Julia REPL, do this entirely interactively. I happened to have started this VS Code session, though, without an expensive GPU attached to it. And so it'll take, on the order of an hour to train my machine, to train my network to a reasonable accuracy. And I don't want to wait that long. I want to try this. I want to iterate on this rapidly and test out different versions, different varieties. And so this script here is actually set up to work nicely with JuliaHub. And I can actually call back into JuliaHub and connect back in and say, hey, let's take this training script, this interactive thing that I've been working on and have been playing with, and I know it works interactively. Let's run it, and I could either spin up a ad hoc distributed cluster with an arbitrary number of nodes, or even with GPUs attached to them, or I could just say, hey, let's do a single process GPU job with a particular GPU attached to it. So that could be a V100 GPU or a K80. You can change these values around as you'd like and play around with them. But this is exactly how you can work with your data and spin off independent tasks that show up as jobs here that we can look at and explore and play. So I can start this job. This will take just about 10 to 15 minutes instead of the hour on a CPU. By spinning it up separately, it actually ends up costing me less than if I would have done this on a CPU, just because the GPU job can spin up, get its work done, and tear down, and be ready to move on to something new. So you can see now I hit that start job. We are waiting for that GPU node to appear and spin up and play around and start training our network. We can go in here and under this actions menu, we can look at the live logs. Right now, it'll bring up a log that just says, hey, we're waiting for our nodes to spin up. There's nothing there yet. We're connecting to the GPU machine, or if I would have done a whole cluster of machines, you'd wait for all of them to connect in. You can go in and see a version that I ran earlier yesterday and look at its results and see this. And we can actually plot the values. Not only can I plot them, after a job is done, but I can, look at the accuracy of my neural network as we've iterated over our data set a number of times, and watch this go. And if this were in the midst of training, we would actually see this live updating as we go through our data set. So you can even peek in on your jobs as they're going. It's trying to make it as little of a black box and make this as interactive as possible, right? Where you can play with these things. And really, we're going to spend more time next week looking at how you structure your data, how you structure your jobs, the kinds of things you can do with these batch processing, and then also looking at deployment after the job is done. Here, though, I'm going to focus on the interactivity parts of it, right? Where we've been seeing this, where we have the training set and these jobs that we submit. Finally, we have these jobs, and you can see here in my job list on my VS Code, this is connected to the exact same job list that we have available to us on JuliaHub. So here are the 3 jobs that are running, that MNIST demo set job that I submitted, as well as my IDE and my Pluto job. If I click more, you can see all the jobs that I've run, including jobs from yesterday and from before. So you can see yesterday I ran the MNIST demo twice, and we can look at the logs in my web browser as well, right? And that's exactly the same log viewer as before. I can also look at the details and see, what these things did. So yesterday when I ran this, I did one of these jobs using CPU processing, where I ran this on CPU resources. And because of the way the Julia ecosystem works, the same code can run both on standard CPUs, on standard machines, as well as on GPUs. So there's no GPU attached here. It trained, it worked, but it took me an hour 35 to do this. And so you can see that there. We can also go in and look at another job that I submitted that has the swanky GPU attached to it, and here it just took 8 minutes to do. So this is where you can really gain huge benefits in using GPUs. You can look at the details and even see some of the outputs that we've stored. And then you can download the results. You can download the stored weights of our networks, right? And I could look at them locally on my computer now that I've downloaded them. But I can also go back to JuliaHub, connect back into Pluto, and spin up a demo, a notebook that will go in and pull in that exact same results table, authenticate back into JuliaHub, show all my results, and allow me to interactively inspect them and play around with them. So give this just a minute to connect in, and we can watch and see how that works.
Hey, Matt.
Yes.
Just curious if you've been watching the chat at all. There's been 2 questions that have come in. It's the same person. It's Willie, and Willie's interested in finding out interacting with Jupyter whether you need to load packages or not. I don't know if you could possibly read that and maybe give me
Sure.
an answer while we wait.
No, that's a great question to tackle now because, we've been focusing on Pluto notebooks. We don't have a Jupyter application, at least not yet. We probably will at some point in the future. But the question about packages kind of applies to everything, right? Whether you're in, oops, I just got logged out here. Whether you're in a Pluto notebook or a Julia IDE session or a Jupyter notebook, we need to load our packages and load the resources that we want to have. And importantly, we don't want to spend all day precompiling packages every single time we spin up a notebook. And those of you who are familiar with Julia know that there can be a bit of a speed bump the first time that you run your packages because you precompile them. And so if we just, if we didn't store the results there, every time you load a new interactive session, you'd have to precompile and wait a long, long time. Fortunately, we do store those things. And so in my VS Code session here, I can actually go in here and look in my file system here. Let's see here. How do I do this? I guess through here. If I go in here, you can actually see in my data folder is where we store our Julia folder, is where we store all the packages that you're using, is where we store all importantly, the precompiled files that you use and work with. And so that is where, those sessions are stored. And because those are persisted, it means that when you load a Julia notebook or a VS Code environment, that environment is cached for you. And so any precompilation work, any package additions that you've done, those sorts of things are all stored for you. Now, with respect to Pluto notebooks in particular, so we can go into this Pluto notebook. The way that this particular Pluto notebook is structured with respect to its packages is that, let's see here, I think it is, yeah, where I have a hidden cell here that sets up all of my my package environment. And if I can find it, it should automatically, yeah. Here we go. So, in this initial cell here is where I'm telling, my Pluto environment where my packages are coming from and which packages I'm using. And the way you do this will vary if you're in a Pluto notebook or in a Jupyter notebook or in a VS Code session, but the same concepts apply no matter where we are. These are the packages that I'm using, and I'm using the PKG package manager to activate the session where I have all of the versions defined for me. The MIT course does this slightly differently. They activate a temporary directory, which seems like it would need to recompile and re-download and get everything set up for you every single time again, every time you launch this. But because of the way the package manager works, this is actually also stored and saved for you. So even though it's activating a temporary directory, and because of all of the way that they do this, this is another way to set up your packages. And so this sets up all of your package ecosystem. And so, yeah, there are two ways of doing kind of the way that you want it. You can either add them and we'll cache the results, or you can activate a directory in which you have your project and manifest defined. Both work and both allow you to do this. And now that this is all loaded here, we can actually go in and load that job that I had run yesterday. Load it up, and here you can see this is exactly that same results table that we can see in VS Code, that we can see in the web on JuliaHub, and you can go in here and test out your models, right? So as I write my handwritten digit, you can see it runs on the model and updates the model's output down here. And you can play around with these. And what's really fun is that as you interactively inspect them, right, you can kind of put in something that's a little strange, or something that's on the edge of what might be considered a 5. And then you can go in and let's make my screen just a little bit smaller so I can show all of these things all at once. You can go in and change your model and look at what the different models do on this kind of strange input. So this one, actually, everyone is agreeing that it's a 5. I can go in and do something a little bit different, right? That's a little bit even stranger. Now I can actually see that my models are disagreeing, because every time I've trained this, I might have actually used different network topologies or different setups. In this case, it's exactly the same network topology, but the random starting point and the iterations, the gradient descent path it took was different. And so the final answer that my weights got is different. And so, you can play around with this, and this is exactly how you can interactively introspect your trained models. In this case, it's a really nice visual example, right, where we can draw in the test data, but you could do exactly the same thing with something that's not as visual as well, right? Generate a phony row of say demographic information for a person or whatever data you're tackling. You can play around with, see what your model would do, see what the outputs are, and use Pluto's really awesome sliders and canvases and widgets and buttons and all sorts of fun things to create kind of your own data scientist's dashboard here, where not only do you have access to the widgets that you've written and the real nice ways of playing around with them, but you also have access to the code itself. So you could go in here, add more plots, play around with looking at what the network weights are doing. You can inspect your networks or whatever outputs JuliaHub is doing. And all we're doing here is downloading the results file that each job has done and created. So with that, we're pretty much at the end of my structured point. I'm happy to take other questions. I see one in the chat now. Let me just jump back to my my presentation, and we can wrap up on the core content, and then I'm happy to play around with things or answer any questions that anyone has. So this is all done through the work that we're doing at Julia Computing, where we're really driving to create a first-class experience on the web, not just for anybody, but also for enterprises and for companies, organizations that need additional requirements as well. So we're able to create JuliaHub enterprise instances and organizations where you're able to have your own dedicated space for your organization, direct billing, all the sorts of things that you need to get your job done. Importantly, it means that you don't need to install Julia on everybody's laptops, right? Everybody has access to the same development environment, the same shared resources, and the same access to clusters at for very large scale compute, ranging from all sorts of folks who are finding this useful and helpful, from pharmaceuticals to energy to medicine and finance, government. So that's who we are at Julia Computing and where we're going. If you're interested in seeing more details about anything that I showed today, you can go back to last week. There's this awesome event called PlutoCon. Lots of really awesome examples of interactive notebooks and things. And I gave a talk there on the future directions of Pluto and kind of the new things that we're doing. Everything that I demoed today are things that are available now. But we have a lot of new capabilities that are coming up. And if you're curious about those, you can go to PlutoCon and find my videos on YouTube, along with all the other really, really awesome demonstrations of using Pluto Notebooks and Pluto's reactivity to putting that to good use. But then also next week, same time, same place, we'll be talking about the other side of JuliaHub, kind of focus more on what it means to have large-scale data sets, what it means to spin up large-scale jobs, focus more on those kinds of cluster, big data sorts of tasks and kind of development of those models, and then as well as the deployment side of things, where you can take this out and step beyond that Pluto notebook into something that is more generally available. So that will be next week. I hope to see many of you there. And with that, happy to take questions. We have one now asking, how is the interaction with non-GitHub repositories, Git-based and other? So once you're in the VS Code environment here, we have access to a full computer. We have access to everything you want. So in the Julia REPL here, I can, for example, go in and just say, hey, let's switch over to Julia's shell mode, git clone an arbitrary git URL. And this could be on github.com, or it could be anywhere that you want to have. You can go in here and grab in any data that you want. You can clone it directly, and this just works. We're connected to the internet. We can do this and grab what we need. So the same works, on your shell. You can even bring up an arbitrary terminal, right, and have access to the machine itself. We can, again, you have access to Git here as well. But you would also have access to other commands, other things. So if you have non-Git based sorts of things, I don't know. I'd be surprised if, I don't think we have SVN installed. We kind of focus more on Git. But, if in particular on our JuliaHub enterprise side of things, we'd be happy to build custom images to make sure that all the tools that you need within your environment are available, both in interactive and non-interactive jobs, to grab out what you need to do and see what you have. But yes, this is a complete computer here. We can go in and even just kind of see what's running, see what tasks are running. You can play around with it. But you kind of have access to arbitrary commands beyond even just those that are exposed here with the nice VS Code extensions. The nice thing about using the Git clone mechanism through GitHub and authenticating there is that this allows you to work with private repositories that are connected to your account, right? You can connect in and connect to private repositories and get those that your account has access to. Where JuliaHub Enterprise takes this one step farther is that, you can, as an organization, add additional registries and have a private registry of packages where instead of needing to clone data, you could just grab into in your Julia session, you could add a private package and it would go out, and instead of trying to do that on the public general ecosystem, when I try to do this, it'll fail because I'm not on a GitHub Enterprise with a custom registry. But this would allow you to, JuliaHub Enterprise allows you to manage your private packages and version them, depend upon both open and closed source packages, and allows you to really grow as an organization in your Julia use. Any other questions about anything that I've demoed today, or other sorts of general JuliaHub questions?
It looks like there aren't any further questions coming in, Matt. I do want to thank everyone certainly for their participation today. And thank you, Matt, for your time and the excellent presentation. For recorded version of the presentation and our past webinars as well, you can visit our resources tab at juliacomputing.com. For any help with your existing Julia applications, use cases, or upcoming Julia projects, please feel free to reach out to us at sales@juliacomputing.com. Be happy to help you. Thanks again, everyone, and have a great weekend. Take care.